Students, let us discuss question number 3 of assignment 3. And I made a video and that is interrupted. So I'm making this one again and I have written this all. So you have to prove that the product of three consecutive positive integers is divisible by 6. You have to check it is true or false and you have to justify your answer also. So here it is clear that since we have to prove this one is divisible by 6 or not, then your divisor always 6. And can you see that this one is your b, this one is your b here, and by Euclid division lemma you already know that a is equal to bq plus r and your remainder always greater than or equal to 0 and less than b. So your remainder can have possible values as 0, 1, 2, 3, 4, 5, and your divisor is 6 here. So the your numbers are of the type 6 cube, 6 cube plus 1, 6 cube plus 2, 6 cube plus 3, 6 cube plus 4, and 6 cube plus 5. When you are putting r as 0, then you will have 6 cube. When 1, then you have 6 cube plus 1, and so on up to 5. So these are the possible numbers when you having the divisor as 6 there. These numbers are always representing the positive integers. Every positive integers are of these types. So we must have three consecutive integers here. So our n is numbers, we are supposing that your n plus 1, n plus 2. Can you see that these are consecutive numbers here? This is n plus 1 and n plus 2, and product of these three is let us take this one as p, and this will be equal to n into n plus 1 n plus 2. So what our motive is, we will take these numbers as n. When you will have n in first case this one, in second case this one, and so on. You will take 6 cases here, and you have to prove that in each case that product will be a multiple of 6. So in case 1, when you are taking n as 6q, then it is 6q, you are replacing this n by 6q, and here you will have 6q plus 1, and here you have 6q plus 2. So can you say that in this whole you can take 6 outside and you can write the other quantity here. So if 6 is common from this one whole, you can say that this whole multiplication is divisible by 6. So the first part is proved here. And in the second case, when you are taking n as 6q plus 1, then your product will be equal to 6q plus 1, and you are replacing this n by 6q plus 1, and here you are writing n as 6q plus 1, and 1 is also here, then 1 plus 1 will give you 2. And also when you put n equal to 6q plus 1 here, and then it will give you 6q plus 1 plus 2 is 3. So can you see that from this one is as it is here, and you can take 2 common from this one, and when you take 2 common from here, then it will be your 2 times 3q plus 1. And when you take 3 common from here, you can take 3 common from this one, and this will be your 2q plus 1, and this 3 into 2 is your 6, and this is 6q plus 1, and this is 3q plus 1, and this is 2q plus 1. And you can see that 6 is common from whole the product of this, and this is also, which is also divisible by 6. So now in case third, we will take as your, in case third, your n will be your 6q plus 2, and when you put n as 6q plus 2 in this product, and that is n, your product will become 6q plus 2. You are replacing n by 6q plus 2, and here you put n as 6q plus 2 plus 1. So okay, you can write this as 6q plus 2 plus 1, that is 3. And here you can also see that you can write this as 6q plus 2 and plus 2, again you will have 4 from here. So you can easily see, you can take 2 common from here, you can also take 2 common from here, but we need only 6, so you can take 2 and 3 from only these two, and you can leave this one, we don't require this one here. And so you can take 2 common from here, and it is 3q plus 1, and you can take 3 common from this one. So you can write this as 2q plus 1, and this is your 6q plus 4. We can take 2 common from, also common from here, but we don't require this one because we need to prove this one is multiple of 6 only. So we are getting 6 from these two only, so we need not to take common from here. So it is 6 into, this is 3q plus 1, and this is 2q plus 1, and this is 6q plus 4. So also you can say that which is also multiple of 6, and you can also say that which is divisible by 6. So now we have on 3 more cases here, and these cases are similar like that. You can prove all of them by yourself. What you will do, I am giving you the hint of that all. This is a process of the question. You can easily understand what I am doing here. I am putting n as 6q, n as 6q plus 1, and n as 6q plus 2. In fourth case, you will put n as 6q plus 3. You will put n as 6q plus 3, and then in case number 5, you will put n as 6q plus 4, and in sixth one, you will put n equal to 6q plus 5. Our motive is to prove that the product will be always having a factor of 6 in all. We are having factor 6 here, 6 here, and 6 also here. In rest 3 cases you have 6 also there, and that is your part. You will complete this question by yourself, and I am giving you the hint what you need to do. This question is not completed yet. You have to complete this by yourself. You will take rest of 3 cases by yourself. If you have any doubt in this one, you can ask me.